Okay, e-learners, we are taking a quiz right now for 10 minutes. Yours will be posted tonight, or if you're reading or if you're watching this video tonight, then obviously it's already posted. Yes, sure, go for it. Yes, sure. Are you done your quiz? Yeah. Yeah, go for it. Should be about halfway through your quiz. That was 5 minutes. Peace. Jaden. 1 minute left. 1 minute left. Anybody still working? All right, let me have those quizzes. Make sure your names are on them. Check, make sure your names are on them. What did I say about Rubik's Cubes? In your bag, not in the desk. Because you will not be able to resist the urge to mess with them. I know I wouldn't. I do quizzes or tests. I'm always afraid that I will lose someone's quiz or test, which is why I personally either stand by the door, you hand it to me, or I come by and grab it. And that way I know now I have no one to blame but myself if I lose one. I think in my entire career I've lost like 2 ever. I feel really bad when I say, hey, sorry, you got to take the quiz again because I lost your test. All right, easy or hard?
Easy.
Good. You all should have A's on that. Get out your homework.
I'm going to get an F.
Hope not.
He always says that. He's an all-A student.
I didn't do it, but I also have a quiz on that. I like it better.
Kaden, what class do you have a B or below in?
A B below it. Right now it's chemistry.
Oh,
So 5.
okay, that was not expected.
What? But that's literally how you answer that.
What is wrong with you?
Okay, let's get things going here.
Stop.
Any questions on the homework? Front and back. Remember I said do not do number 13. How many did 13? What's the answer on 13? Good job, Smarty Pants. We haven't done negatives yet, but yes, you were correct. Yes. I'll give you one. All right. Okay. Let's grade this. Here we go. You tell me if I'm right or wrong. I'm just going to call out what I see. Yes. Let's grade this puppy. All right. Here we go. Number 1, x equals 12.
Correct.
Number 2, n equals 5.
Correct.
Number 3, p equals 11.
No.
Wait.
No.
4.
G equals 6.
P equals 6 is correct. All right. Number 4, x equals 6.
Correct.
Now, if you wrote 6 equals x, that's the same thing, right?
So I did that with some blank, but it's
You can't, because remember, x equals 6 is the same as 6 equals x. Either way is fine. The book, whenever you check your answers, will always put the variable first. Even if the variables start on the right side, they're always going to say x equals whatever. All right, number 5, n equals 2.
Correct.
No, n equals
10.
10. That's correct. Number 6, b equals 8.
Correct.
Number 7, x equals 4.
Correct.
Number 8, a equals 13.
Correct.
What's 10 plus 3? Not 33. All right. Number 9, let's see, n equals 12.
Yeah.
Number 10, b equals 13.
Correct.
Number 11, n equals, well, 0.
No.
No, 2. All right. Number 12, n equals 8.
Correct.
You got all the subtraction ones. The ones you're having issues are the addition ones. That's crazy. You kids get the subtraction ones wrong. The addition ones right. Number 14, n equals 5. Number 15, a equals 10.
Yes.
Where are you getting an 18 from? Yeah, no, it's 9 minus 9.
Wow.
Number 16, let's see, m equals 4.
Yes.
Number 17, x equals 3.
Yes.
Number 18, n equals 11. Number 19, r equals 1.
Yes.
Whoa.
Yes.
Sounds like the class agrees with me. What's 11 minus 10? That's why the answer was 1. And the last one, x equals 15. All right, I gotta help you. A lot of you. Yes.
For every answer, every single one I did x equals the answer.
That's
not
fine.
so even if the variable is n, it's still fine if I did x.
Oh, I got you. No, actually, you need to write the correct variable.
You better do it now.
It's okay. That was day 1 of solving equations.
So that
We'll fix it.
that'll still be fine.
Well, you're just not gonna make that mistake tonight. Huh?
Better.
That's not like homework. Make sure all the homework makes it into the basket. For those of you that are challenged to putting things in the basket. All right. Everyone else, look at the board, copy down your homework. Hey, we just took a quiz. The next important thing is on,
Monday.
heck yeah, it's 3-day weekend.
Monday.
All right. So the next important thing in math is on next Thursday, test. All right. Labor Day. All right, there's your homework copied down. Hey, it's another worksheet. Do not get comfortable with worksheets. Yes, for the next at least 3 homeworks, there will be a worksheet, but we're not going to do worksheets the entire year. Most of the time, it's straight from the book. It's getting lukewarm, so.
You have to drink it faster.
Chug.
No.
That is pretty wonderful.
This one's for you.
Thanks, sir.
Because that's what men wear.
All right. So here's the deal. We're going to do something very different today. You have not done this before, thank you. Yesterday, you did something brand new and you took to it like fish to water, right? Solving equations, not that big of a deal. And I'll just say, in general terms, solving equations in algebra is the one thing that most students, even the complicated ones, they're like, okay, I know how to solve an equation. There's other things in algebra that students are not comfortable with. But solving equations is one of those ones where you got these nice straight rules. Nothing varies one way or the other. It's not like, well, this time I do it this way, the next time I do it a different way. Most kids are pretty good at solving equations. So you've begun your journey to solve even more complicated ones. Today, we're going to see a different form of solving, okay? All right, the section was entitled, hand sanitizer, please. The section, and bless you, the section was entitled Solving Equations, and yesterday we solved no inequalities, so that's what we're going to do today. Tomorrow, we'll do the same thing, but with multiplication and division for both equations and inequalities, and that's kind of how this section or this chapter on solving ends up. So we got to do inequalities today. So as a quick reminder, I said for 3 days in a row, we are going to write down the 3 key ideas of algebra and the steps to solve algebra. I said we'll do it 3 days. We won't do it a 4th day if you can show me by day 3 that you have these memorized. All right, so here we go. Box number 1 has 3 boxes. The 3 key ideas of algebra. Anybody remember one of them? You wrote them down yesterday. You got one?
Get the variable by itself.
That's number 1. Let's write that down, please. Oh, by the way, remember, for all of algebra, we cut equations, you'll find out inequalities as well, too, in half. We make a left side, we make a right side. The book abbreviates LHS and RHS. So algebraic equations are equations that have at least one variable. You can have more, but we will not see that this year. The 3 key ideas, next year you will. The 3 key ideas are, number 1, get the variable. You can just write down what's in red today. Get the variable by itself. This is called isolating the variable. Most math teachers say, yes, isolate the variable, but I'll say just get it by itself. And by itself, I mean you take this big honking thing, you do some algebra, and eventually you get to where the x is on one side, the right side or left side, all by itself. Yes?
If it's easy, if you understand what isolate variable means,
You can write isolate the variable, sure. Yes?
whatever you do to the left side, you have to do.
Oh, he's already giving me the second one. You ready? The second one, right? The second one says, whatever you do to one side, you must do to the other side. In algebra, we keep things balanced. When you take the course called algebra, and I tell you where algebra came from, anybody know historically where did algebra come from? Did not come from Einstein. It came many, 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 many centuries before Einstein.
It's the algebra. From the Greeks.
It didn't come from the Greeks. It actually came from the Persians. And there's a famous guy named Al-Khwarizmi. He's the reason why you study algebra. But we'll learn about that in algebra 1.
Well, I hate him.
All right. Yes, and as soon as I show that to many algebra students, he does become the person of interest. Okay, so whatever you do to one side, you must do the other side. If I have an equation and I want to solve it, and I decide to add 10 to one side to keep the equation balanced, I must also add 10 to the other side. If you don't think of a balance in science class, one of those balances, it doesn't become balanced anymore if you only add 10 to one side. So if I add 10 to the left side, I must add 10 to the right side. That is correct. Okay? Yes, you had a question? Go for it. Oh, yeah, we're not talking about that yet. All right, last one. So in algebra, we try to isolate the variable, get it by itself. So that means we need to get rid of things. Key idea number 3 says how you get rid of things. To get rid of things, we do inverse operations. You identify what you want to get rid of. I want to get rid of that 2. Well, the 2 is attached by addition. So to get rid of a plus 2, we subtract 2 from both sides. Those are the 3 key ideas of algebra. Hey, get the variable by itself. Whatever you do to one side, you must do the other side. And then to get rid of things so we can isolate the variable, right, we do inverse operations. This year there are 4 of them. The inverse of addition is? The inverse of subtraction is? The inverse of multiplication is? Haven't done that one yet. The inverse of division is? Okay, so intuitively we know those inverse. There are more. Intuitively know those inverse operations. Check it out. The 10 is attached to the x by subtraction. I'm subtracting 10 from x. If I want to do the, well, reverse is not the right word. We also don't use the word opposite. We keep up the word opposite for another thing in math. But if I want to get rid of subtract 10, the inverse of subtraction is addition. So I need to add 10 to both sides. And that's what gets rid of 10. So when you actually add this, Jaden, pay attention. This says 10 minus 10. What's 10 minus 10? You were putting 20. That was your issue. 10 minus 10 is 0. 10 plus 14 is 24, right? I'll go ahead and show you a 2-step equation right now. Hey, how's the 2 attached to x? Well, what's the inverse of multiplication? Let's divide both sides by 2, and what do you get? X equals 12. There you just did your first 2-step equation. Right? That's how it's done. All right, there are the 4 inverse operations. This is all review from yesterday. We took this in our notes yesterday. Okay, so there are the 3 key ideas. It should be the same thing what you have in box number 1. Box number 2 are the, okay, these are the ideas. These are in the back of our head whenever we're doing algebra. But to actually do algebra, sit up, please. To actually do algebra, we have steps, okay? So remember the key idea, we're trying to get x by itself. The steps are here. Write this down, box 2. So you always ask yourself these 3 questions in the one statement. The 3 questions, you just start. Hey, you look at the algebra equation, it says solve. You say, okay, variable by itself. Usually the answer is no. When the answer is yes, you're done. But if the answer is no, you go to the second one, which says, well, if it's not by itself, that means there's stuff attached to it. How many things attached to it means how many steps you have to take. Hey, there's only one thing attached to it. That means it's a 1-step equation. So you say, what's attached? Hey, that 10 was attached to the x. How it was attached? It was attached by subtraction. Well, then you do the inverse of subtraction, which is addition. You can repeat this process. Then you go back to the first one. Okay, is now the variable by itself? Well, the previous one we said, no, it's not. There's a 2 attached. How is it attached? It's attached by multiplication. We did the inverse. We divided both sides. But we still keep box number 1, that key idea of whatever you do to one side, you must do the other side in mind. But these are the, I don't know, the steps that you just say to yourself over and over. If I'm your math teacher for the next couple of years, you're going to hear me say this all the time when we do an algebra equation. Hey, where's the variable? What's attached to it? How's it attached? Do the inverse. I never have any students ever get anything wrong when I say this, these 4 things right here, ever. Yet I'll have students get things wrong in algebra. Well, 2 reasons. 1, a calculation error, 2 plus 2, they put 5. Or for some reason, they think I don't need to say to themselves. These are kind of like the internal words that are going on in your head. But as soon as you say, I don't get this, all Mr. C does is simply read this to you. Where's the variable? And you go, oh, it's on the left side. What's attached to it? A 2. How's it attached? Multiplication. What do you do to both sides? Everyone always says the right thing. It's amazing. So try to keep this in the back of your mind. All right, we're going to write this down one more time tomorrow, and then we'll do the same thing next year as well, too, if you have me. But we won't write it down a 4th time if you have this memorized. Question? Okay. This is what you had last night for homework. So who am I going to pick on? Who am I going to pick on? Thank you, Felicity, for volunteering. Felicity, where's the variable, left or right side? Is it by itself? So she finds the x, it's on the left side. Remember, we talk about left side of the equal sign, left side. It's not by itself, Felicity. What's attached to it? 2. How is the 2 attached to x? How do you get rid of addition? So what are we going to subtract from both sides? 2. So we got to keep it balanced. So we got to do it to both sides. So we subtract 2 from both sides. We draw this long horizontal bar. We don't draw 2 of them, one here and one there. You'll see why tomorrow's class. One long horizontal bar, we do the subtraction. 2 minus 2 is, 5 minus 2 is, and I said yesterday that this step right here you can skip, because what is x plus 0? X, right? Anything added to 0 is itself. And so you can jump right to the answer. It's not that skipping a step is a bad thing. It's just like, once you do this about 10 times, you're like, okay, I'm kind of done with this step, right? Questions on what we did last night for homework. The mistakes that I will see occasionally, someone will subtract 5 from both sides. You're not going to understand why. There's 2 numbers up there. It's got to be one of the 2. But remember, 5 is on the right side. It's not on the same side as the variable. So you're trying to get rid of the things that are on the same side as the variable. All right, the other one was subtraction. Jaden, this one's yours. Where's the variable? Left or right side? Left side. What's attached to it? How's it attached?
Subtraction.
How do you get rid of subtraction?
Addition.
So what are we going to add to both sides?
3.
We're going to add 3 to both sides. We draw a long horizontal bar for addition. 21 plus 3.
24.
And this was your mistake. 3 minus 3.
0.
0. Now, notice the pattern I just did. I said top to bottom. 21 plus 3. When I went to the subtraction, I said 3 minus 3. I went bottom to top. There's a reason for that. You guys don't know anything about negative numbers, so we choose at this stage to frame the question from bottom to top. Technically, it says -3 plus 3. Since you guys don't know negative numbers, if there's subtraction, we're going to go bottom to top. Now, if you do know negative numbers, -3 plus 3 is still
0.
It's still 0, but you guys don't know negative numbers. Okay. So we still get 24. All right, do me a favor, do box 3 all by yourself. Do box 3 all by yourself. Anybody need help right off the start? I got a lot of things wrong on the homework last night. I need someone to help me make sure I'm doing this correct. All right. First one, where's the variable? So were you adding or subtracting 2 to both sides? Okay. Yeah, remember the subtraction one, left side. That was good. All right, the next one. So how is the x? So how is the 14 attached to x? So what's the inverse of subtraction? So let's add what to both sides? So plus 14 plus 14. Make sure you put plus, because otherwise, make sure you put plus goes on the other side. On both sides before you do any addition. Finger and toe. The horizontal bars all the way across. There you go. Gives you, therefore the answer is, so 14 minus 14 is not 28. Yeah, because that's what that minus sign. So we're ignoring the x. We're just looking at those two numbers. 14 minus 14 is, it is 0. So that means the 14 went away. And now you're only left, 14 goes away, and you're only left with what's also on the right side of that equation. What's on the right side of the equation? Visually look, what's on the right side? You didn't do anything to x, so it's just right there.
Okay.
That's the answer. Let's do this one. Plus 16. Plus, I want you to write plus 16, plus 16. I want that to be the first thing you do before you do any addition. Okay, 16, and that's a big number, right? And then 16 minus 16 is, right? And then, but you're left with, so therefore the answer is, perfect. Now do the addition.
I was just confused.
You're confused on the subtraction. Right here.
Yeah.
That's the only thing that you're, or sorry, on that side. The side that has the x on both times. It's only day 2. All right, we good? All right, class, upper left, what's the answer?
X equals 19.
X equals 19. Oh, I don't have the answers there. So x equals 19, upper left, lower left.
X equals
X equals
88.
88, that's correct. Upper right,
X equals 16.
x equals 16, and lower right.
X equals
Sounds like you guys got this, right? All right. So we solved by subtraction. We subtracted something on both sides. We solved by addition. I think we're done. I mean, what we haven't done is multiplication, division. That's tomorrow.
12.
I did, and as soon as yesterday I reviewed what I had to teach today, I was like, oh, I said it backwards. Yesterday I said we're going to do multiplication, division today. We're not. We're going to do inequalities today. So today's class, what's left is we're going to do the same thing. Please stop that, please. Thank you. But with inequalities. Now, on the quiz you just took, you wrote inequalities. Today we're going to solve. Now, it's a good news, bad news. Which one you want?
Bad news.
Bad news, we got to graph all answers. When you solve an inequality, you have to graph your answers. We will get to an answer just as easily as equalities. You're paying attention? But we got to graph our answers. How many people already know how to graph an inequality? No hands. So we better talk about that first. So, graphing inequalities. Now you got to pay attention. Brand new. You've never done this before. It's easy. Okay? So, an inequality, right? Let's just contrast that with an equality first. Okay? Eyeballs on the board, please. Hey, is this an equality or an inequality?
Equality.
Well, how do you know that?
Because
It's got an equal sign. Okay, great. So with an equality, what it means is that the left side
it's equal to the right side.
equals the right side, or has the equivalent value. 2 plus 6 is the same as 1 plus 7, right? We say the left-hand side is the same as the right-hand. Not visually, 1 and 7 are not the same as 2 and 6, but their values, right? When we add to the addition, there is the same. Is that true with inequalities? Heck no. The left-hand side does not equal the right-hand side. That's the definition of an inequality. In fact, one side is bigger than the other, okay? We use these two symbols. You're like, well, what happens to less than or equal to, greater than? We'll talk about that, not today, but later. We do have 2 more inequality symbols. So the less than symbol, the greater than symbol, we talked about that already in this chapter. Okay, one of those symbols goes between. The one that you choose is, well, which one is the larger of the 2 values? Okay, so inequalities. Oh, wait, that's not an inequality. That's an equality. Turns out that you can write an equality 2 ways. Here's one way. What's the other way? X. Yeah, I could also write 4 equals x. That same concept that you can write an equation 2 different ways also applies to inequalities. Hey, there's one way. What's the other way? I got somebody giving me, no, you did it right the first time. So what's the other way of writing that inequality? Go. 4 is greater than x. Notice I'm using a completely different symbol. This is the less than symbol, the first one. And the second one is a greater than symbol, but it still says the same thing. It says x is smaller than 4. If I read the bottom one from right to left, it still says x is smaller than 4. Everybody with me? Okay, cool. So I said we're going to talk about graphing inequalities. No one said that they've graphed an inequality before. So we're going to write down the short, easy steps. It's easy to graph an inequality. For equations, have you ever graphed a x equals 3 before?
Yeah.
No. If I did have to graph x equals 3, what would I need?
Graph.
Oh, I need a graph. We call that, in math, we call that a
coordinate plane.
coordinate plane would be graphing a point. We'll do that this year. But to graph just x equals 3, what do I need? I need a number line. Okay, there's your number line. What do I do?
You mark 3. You put x at the 3 spot.
I just literally put a dot on the 3 and I'm done. Does that seem like we just did a whole lot of work?
No.
Does it seem like we accomplished anything? No. This is why we don't graph equalities, because there's only one answer, x equals 3. It's kind of, I don't know, it seems like a waste of time to don't do a number line with one dot on it. Okay? That changes when we have an inequality. On an inequality, how many numbers makes this true? Give me a number that makes it true.
2. X equals 2.
2 would make it true. What else?
1.
1 would make it true. What else?
0.
Okay, well, the negative numbers that we haven't talked about would make it true as well, too, but then also all the fractions would make it true, right? All the decimals, 1.2 would make that true. The issue is that there's lots of numbers that make it true. Now it becomes more interesting if we have to graph that. Okay, ready for your mind to go, how many numbers actually make this true?
1.
Yeah, and we have a word for that in math. Infinite. Now, I have not used that this year. I'm not going to define it right now, but I just want you to realize infinity is not a location. It's not like I add some special numbers and I get to infinity. It's not like infinity is a house and I'm walking towards that house. Infinity is the concept that no matter how close I get to the infinity house, the house keeps moving away from me. The biggest number you can think of, you can always
Add just 1.
add 1 to it, and it's a bigger number.
So it's like the stretching
Infinity is the concept that it just keeps getting bigger.
So it's like a stretching hallway.
It's a stretching hallway. You're like, oh, there's the candy, I want it, and it keeps going further and further away from you. You never get to infinity. Well, I shouldn't say that. Infinity is the concept that the numbers keep getting increasingly larger. Okay, so write this down, please, box 4. These are supposedly the easy steps to graph an inequality. Now, if you've had a different math teacher, some math teachers make you make a complicated number line. I am the opposite of that. I'm going to make you make the least complicated number line ever. How many tick marks will be on the least complicated number line ever?
1. As many as
How many tick marks would be on the least complicated number line that
None.
exists?
0.
1. Well, then there wouldn't be a number line without tick marks.
No, you can do
It would be a line. But if the number line, we got to have a number on it, right? 0 is still a number. But 0 numbers would be just a line. We need a number line, so we need at least one number.
0.1.
Our number line is going to have one number on it.
What?
Okay, here we go. Write this down, please. Your first step to graph any inequality is to draw a number line. A number line has arrows on it. Arrows indicate that the numbers continue to get larger and continue to get smaller. So you need arrows. Yes, I will take a point off on the test. You don't put arrows on your number line. Step number 2, you will put one tick mark dead smack center. No, it will not be 0. Number 3, just write this down. It will make sense when we do an example. You're going to write the number. Doesn't make sense now, but it will here in a second. Step number 4, and it's the hardest one, you will put an open circle. I'm exaggerating. You're going to put an open circle around the tick mark. Step number 5 actually is the hardest one. Step number 5 is this, and there's only 5 steps. You're either going to shade to the left or you're going to shade to the right. That won't make sense to you now. It will in a second. Hey, calculators away, please. So it's 5 steps. This 4th step right here next to you will change. Sometimes you will put a closed circle. Closed circle just means a filled-in circle. For this year, it's only going to be an open circle. If you have the 5 steps written down, did you hear me say that this is easy?
Yes.
It is, except for the last step. I will help you. All right, here we go. Graphing an inequality. What's this inequality say? X is smaller than 3, yes? How many numbers are smaller than 3?
2.
An infinite amount of numbers are smaller than 3. So we need to graph an infinite amount of numbers. That's hard. But our method will be able to do that. Watch how that works. Step number 1 was what?
Draw a number line.
So all I do is make a line, 2 arrows on the end, draw a number line, boom, done. Step number 2 says to
Put a tick.
smack dab in the middle, 1 tick mark. Okay, done. Now you know what a tick mark is?
Yeah.
Okay, step number 3 says what?
Write the number.
Well, underneath the tick mark, you're going to write the number. How many numbers are up here?
1.
So guess what goes underneath of it?
3.
Not 0, right? Now, if this number was 0, then yeah. Number lines do not have to have 0 in the middle. Number lines go on forever to the left or right. Hey, give me a number that's to the right of 3.
10.
Give me a number that's to the left of 3.
Minus 3.
Negative.
This is why we don't need to put more than one number on a number line, because we know all the numbers. The numbers that are to the right are bigger. The numbers to the left are smaller. For the math teachers that make you write lots of numbers, well, they're giving you extra work. If you've got to 7th grade and you don't understand that the numbers are smaller to the left and bigger to the right, you have issues. Okay. Step number 4. I mean, there's more to step number 4, but you won't see it until next year. It says put an open circle. So watch what I do. I'm literally going to put an open circle. That open circle, as opposed to a closed circle, means that the answers do not include 3. Is 3 smaller than 3? That's why it's an open circle. If it's a closed circle, it means include 3 in the answers. This year, it's an open circle. The last step is the hardest one. It says shade left or shade right. You ready? You got to pay attention. What does this say? It says that the solutions are what? Bigger or smaller than 3? So where are the numbers that are smaller than 3? So we are going to shade to the left. Now I always get some smarty pants that says, oh, you just shade in the direction of the arrow. What if it was written that 3, what does that say now?
You shade to the right.
What does this say? It still says that the solutions for e-learners, I'm writing 3 is greater than x. This says from right to left, what does it say? X is smaller than 3 if I read that. So it's not that the arrow that you're shading always points in the direction of the inequality, right? So you got to be careful. So once again, you're just going to read it. I can read it, and I always say to the students, read it from variable to number. Variable to number, variable to number, variable to number, just read it. 3 is smaller than, X is smaller than 3. X is smaller than 3. Where are the numbers that are smaller than 3? They're to the left of 3. Yeah. This says X is smaller than 3. This means the answers are smaller than 3. Like 2 is smaller than 3. 2 is less than 3. So where's 2? 2 is to the left of 3. Point being is that the arrow doesn't point in the direction. The direction that you shade makes this true. Now, yes, you can come up with special rules. I just read it. Yeah.
So do you have trouble teaching that on e-learning since everything's reversed?
Well, typically I didn't think about this on e-learning because I usually just do what I literally just do right there, which is right on the board. But now, since I don't, I'm thinking maybe next year I need to have it on the slide. Yes. So books do it differently. Some books will just make a big thick line that's pointed to the left. Me, I just put a wiggly line that points to the left. You're indicating where are the answers. When I said, hey, you got to write an infinite number of answers, he says, well, that will be very hard. Well, guess what this arrow means? Never stops. There's your infinity right there. Never stops. All right, let's do another one. Step number 1, You draw a line. Lines have arrows on the end. Step number 2, you put a tick mark. Where?
In the middle.
Right in the middle. Step number 3, you write that number. What's the number? Okay. Step number 4, you put an open circle. Next year it'll be open or closed. Step number 5, we're going to shade left or right. I'm going to read from variable to number. Variable to number. This says that the solutions are smaller than 1. The solutions are small. N is smaller than 1. Where are the numbers that are smaller than 1? To the left. Yes? Okay. Number line. Tick mark. What's the number?
0.
An open circle. Read it. The solutions are bigger or greater than 0. Where are the numbers that are bigger than 0? To the right. So I shade to the right. It is easy. But remember, you didn't know this before you walked in today. Does this say something different, or does it say exactly the same?
Exactly the same.
So you got to be careful when the variable is on the right side. I'm going to read from variable to number. This says A, or the solutions are bigger than 0. The numbers that are bigger than 0 to the right. Like I said, I always get the one kid that says, you just look at the arrow and you shade in the direction of the arrow. It's not true when the variable's on the right side. And then I'll get the other smart kid who will say, well, if it's on the right side, it's just opposite. Well, now you have 2 different rules. Great. How about you just read it? There's one rule. All right, here we go. Box 5. Let's do it together. Here we go. Box 5. Draw me a number line. That's step 1. This should take you all of 8 seconds to do. Now I'm going to talk you through it. It's going to take more. I'm saying when you're doing it by yourself, it's 8 seconds. Draw a number line. Put a tick mark. Put an open circle. I don't care how you read it. The top one or the bottom one here. If I read the bottom one from variable to number, it says that A is smaller than 2. If I read the top one, it says that A is bigger than 3. So here's the top one. A is bigger than 3. Well, the numbers that are bigger than 3 are, well, those are to the left of 3. Sorry, oops, to the right of 3. The second one, different problem. It's still a number line. It's still a tick mark. It's the number what this time? 2. Which way am I shading? To the left or to the right? I'm shading to the left on the second one. Why? Because it says the answers or the solutions or A is smaller than 2. Where are the numbers that are smaller than 2? To the left. I feel like I'm going too fast. Am I going too fast? Okay. Going too slow?
Yes.
All right. So what did this all involve? Well, remember, the title of this was solving inequalities. We just graphed inequality. We didn't solve anything. So let's see how to solve. Hey, the only difference between last night's homework and tonight is that you must graph every answer. Tonight for homework, I am very nice to you, and on every single problem I have given you a graph. Now, since a computer generated this, not me, I did not do this myself. It has more than one number. So yours will not be always smack dab in the center, meaning like where your circle will be, but you'll be able to figure this one out. All right, so here we go. So we are going to solve now inequalities. Inequalities. So for an equation, to solve this, what would I need to do to both sides? To get rid of addition, you add more? I'm going to subtract. So what am I going to subtract to both sides? 3. Stay with me, Ace. Right? So therefore, x equals 2. We do not graph equations. We graph inequalities. So when you get to inequality world, notice what's the difference between the two problems. Literally, what's the only difference? One doesn't have an equal sign. So the big difference is that we have to graph the answer. We still get to the answer the same way. Where's the x?
On the left.
What's attached to it? How is it attached? So what are we going to do to both sides? We're going to subtract 3 from both sides. We still get an x and a 2, but we have an inequality. Make sure you write. Sometimes kids will flip the sign around. by accident, we still get that. And then the last step is, because it's an inequality, we must. So, walk me through it.
You need to draw your number line.
Number line,
And then you're gonna need to make a
tick mark.
Label it
2,
Open
open circle, shade to the left. See how quickly? He did that in less than 8 seconds. He probably did that in 5 seconds. Now, I'm not saying like, oh, look how quickly I can. Done. You know, it's not a race, but I'm also saying it's not like it's a 5-minute deal. It's at most 10 seconds doing it nice and neat, which that clearly is not nice and neat. All right. Feeling confident? All right. So inequality. Let's do this. Go. What am I going to do? Subtract 15 from both sides. What he didn't say was, not that you have to, because he's comfortable with it now. Hey, where's the variable? Left side. What's attached to it? 15. How's it attached? By addition. How do you get rid of addition? Subtraction. He just immediately said, oh, I know what to do. Subtract 15 from both sides. 30 minus 15. So therefore the answer is, be careful.
N equals
Absolutely wrong. Absolutely wrong.
You grab it.
Is that an equation symbol? Ah, yeah, we're in inequalities now, so it's not going to be the n is equal to 15. N is less than 15. How do I graph that? Number line? Tick mark? 15. Open circle, you forgot. And then, which way am I going to shade? The solutions or the answers are smaller than 15. That's to the left. Yes? So you tell me. Same or different than last night's homework? Except for the graphing, right? Everything else is the same. And the graphing, literally, I just picked 2 kids at random, and they were like, okay, I got this graphing thing down. Now, you don't have me for next year, and you have this again, and it'll be more complicated inequalities. The teacher might say, lots of teachers also will say, I want you to put a couple extra numbers. If you do this, could you graph a couple extra numbers very easily? If I put one more tick mark to the left, what would be the number? If I put one more tick mark to the right, what would be the number? For me, I'm just saying that just seems like extra work. I don't have any kid that ever tells me the wrong answer. 23 is to the left. That just doesn't happen. So it just seems to me like putting those extra numbers just seems like extra work, which is why I don't require it. Okay, here we go. Go for it.
So we have 7 plus D in that symbol 12. So we use subtract 7 from 12.
Subtract 7 from both sides.
And then that would be
12 minus 7 is
yeah,
not 10.
5.
It's 5. 7 minus 7 is 0. So what are we left with?
So we're left D that symbol 5.
So yesterday or 2 days ago, I said that I have kids in 7th grade that can't tell me what that symbol.
D
Here we
is
go.
less than.
Nice guess, but no. I have kids that can use that symbol, no problem. I'm sure he got correct on his quiz, but he's still working on what's the name of it. As you read from left to right, did you come to the opening or the point first?
It's greater
It is the greater than symbol. Okay, how do we graph? Go.
So we've drawn number line.
Number line.
Tick.
Tick.
Line. Close circle.
Open circle.
Open circle, and then we have the squiggly line or the shape of the right.
To the right. Anybody know when we're going to use the closed circle? When will it be closed?
Not sure.
When it has
an equal sign.
a line underneath of it. This says that D is greater than or equal to 5. That's when we'll use a closed circle. We won't see that. All right. But we will next year. All right, box 6, we'll call it a day. Go. We did not get to subtraction, but you guys will be okay with that.
Oh, I know.
We didn't do any ones where we didn't get any ones where we had to add something to both sides. But you guys can handle that. Are you waving or you have a question? What's your question? No. When you get to your answer, that's what we're going to put on the number line. So it's not the number we're subtracting, it's the answer. First one, what are we doing to both sides? Subtract what from both sides? Okay, so I'm not going to put 7 on a number line because 13 minus 7 is 6. The number I'm going to put on the number line is, you have it now.
Oh,
So let's see, go ahead, give me the graph.
it's let's see, and the answer is 11.
Give me the graph.
6 in the middle and you shade.
6 in the middle, shade to the left.
Oh, shade to the left.
Why is it shade to the left, not shade to the right? Jaden? I'm going to read it from variable to number because it says J is what?
J is.
That's greater than, that's smaller. All right. Grab your homework on your way out. On your way out. Once again, it is 20 problems. It should take you all of 5 minutes to do this. 15 minutes if you're slow.
I am social studies.
Whoa, grab that.
Actually, in my next here in my 140.
Hey, who was it? Was that you, Abby, that needs homework?
Dude, is that yours?
Is that better?
Come on, G.
All right, we should get-
Okay, I'm gonna leave mine.
I'll get you, Yes, you did this before, Gavin? Ace. Have you ever done crappy? Get one already? Doesn't have another homework. Yes, no? Yes? You get your homework?
Oh, you dead? One dirty old guy. Oh, where did All right, e-learners. If you have any questions, send me an email.